So, hello again. In this lesson, we're going to be developing our knowledge of trigonometry even further so that we can find hypotenuse or the adjacent sides, that should be the hypotenuse, or the adjacent sides of a right angle triangle given an angle. So this will basically allow us to solve that problem I mentioned in the last video, last video, with the ship out to sea. So this is why trigonometry is so useful for navigation and bearings, things like that. So to start with, hopefully you've got the sheet that I've put on Teams for lesson 3, or you're just following your book. If you're following your book, just draw the diagrams, have a title and a date, and everything. And then please have a go at the starter. So I want you to find the missing side of the triangles below, remembering less is more. So label, equation, select, solve, and your Sohcahtoa. And then, once you've done that, I want you to solve the equations for x. So try to jog your memory regarding rearranging equations. So just do your best, pause the video, and then we'll go over the solutions. Okay, so for the first problems, which are relevant to what we've just done, we've got our first triangle, we want to find W. So I'm going to write less. So I want to label the triangle. So I've got my 40, always start with the right angle, sorry. Opposite to the right angle is 16, that is my hypotenuse, the longest side. Opposite to the 40 is W, that is the opposite. And then the remaining side would be the adjacent. So I've labeled my triangle, that's done. The equations, so Sohcahtoa. So let's see, I want to find the missing side, W. So I want W, which is the opposite, and I've got the hypotenuse. So that means I'm going to use sine, because I would tick that twice. These ones only get one tick, so I would use sine. So that's my equation. And indeed, I've now selected my equation, so I can form an equation for W, sorry. So I can write sine 40, so sine of 40 degrees is equal to the opposite, which is W, over the hypotenuse, which was 16. And then to solve for 16, I can multiply both sides by 16, which will leave me with W is equal to 16 multiplied by sine of 40 degrees. And if I put it into my calculator, so there we go, I'm going to get 16, help if it was on, 16 times sine 40 equals, and I get 10.28 to 2 decimal places. So remember the units, 10.28 centimeters. For the other two, so for the x, you should get, do this a bit more quickly, for the x, you should get 3 root 2. Obviously, make sure you show your workings, which is about 4.24 centimeters. And then for y, you should get sine 60, or tan 60 is y over 2, so you should get 2 tan 60, which is 2 root 3. You should get y is roughly 3.46 centimeters. Great, so hopefully you have those. Now, solving the equations for x, so I'm just going to move my page down if I may. So solving the equations for x, my first equation, a, I've got 4 is equal to 2 over x, so 2 divided by x. Now, we need to rearrange this in 2 stages. So my first step is to multiply both sides by x. Now, you might be wondering why I'm doing that. Well, the reason is I don't want the x to be on the bottom of one of the sides. I don't want it to be a denominator. I want to end up with a situation where I have x equals something. I don't want to have 1 over x equal to something. So we multiply both sides by x. That cancels out the x's on the right, because imagine I had 2 over 3 imagine I had 6 over 3 multiplied by 3. Well, 6 over 3 is 2. And then if I multiply that by 3, I would get 6. So in fact, the 3's have really just cancelled out. And it's the same with the x's. They're going to cancel out. X divided by x is 1. So on the right, I would just have 2. But on the left, I have got x times 4, which, if I remember, is just 4x. So I now have 4x is equal to 2. So that is 4 times x is equal to 2. And I want to get x on its own. So remembering the opposite of multiply is divide. So I can divide both sides by 4. On the left, my 4's are going to cancel out because I've got 4 multiplied by x divided by 4. The 4's cancel out. On the right, I have 2 over 4, which simplifies to 1 over 2. Which gives me a solution of x is equal to a half. For B, so let me just clean this up a little bit. For B, we have 3 over x equals 6. Same procedure, we're going to multiply both sides of the equation by x. So on the left-hand side, my x's will cancel out, leaving me with just 3. And on the right-hand side, I get 6 times x, which is 6x. So 6 times x. So now I end up with 6 times x is equal to 3. Well, the opposite of multiply is divide. So if I want x on its own, I just need to divide both sides by 6. On the left-hand side, the 6's cancel out. On the right-hand side, I have 3 over 6. So the result of all this is just x is equal to 3 over 6, which is 1 over 2 or a half. And finally, C is a bit trickier. This isn't really relevant today. I just wanted to jog your memory. These A and B are relevant. C is a little bit more tricky, but no problem for us, I guess. We have 12 is equal to 3 plus, I believe I did 6 over x, yeah. Okay, so let's have a go at solving this. Whenever you're solving an equation, by the way, it's sort of like bid maths in reverse. We're trying to undo things. So first of all, ultimately, I want x on its own. But before I can get x on its own, I've got to get 6 over x on its own. So to that end, let's get rid of this 3 first. So I have 3 plus something. I just got 3. So to remove 3, I just need to subtract it from both sides because it's not being multiplied by anything, nor is it being divided by anything, nor is it dividing anything itself. So I just subtract 3 from both sides. On the right-hand side, I have 3 take away 3. They're going to cancel out. On the right-hand side, I get 12 take away 3, which is just 9. So I get 9 is equal to 6 over x. Okay, great. Now we have an equation much like the 2 that we just solved. I can multiply both sides by x, which on the right will mean my x's cancel out, and on the left just means I multiply by x. So that means I have got 9 times x is equal to 6. Opposite of times is divide. We can just divide both sides by 9. So I get x, as an arrow implies, x is equal to 6 over 9, which simplifies to 2/3. So let me just zoom out a little bit just so you can get an idea of everything. So first questions were just finding the missing sides, and then these are the answers. The second one's x is a half. X is a half for the second one too, for B. Then for C, x is 2/3. Okay, so if you are unsure of that, just let me know on Teams. I'd be happy to go over rearranging in more detail with you. So what we want to do is apply what we've learned, so about trigonometry, and what we know about rearranging simple formulae to extend the number of problems that we can solve with trig. So we want to find the missing. So for example, 1, you have this on your sheet, or if you follow it in your book, just pause the video, make a copy. No problem with doing that, as long as you're following it and getting notes down. You want to find the missing side of the right angle triangle below. So that's this one here. So we start off same way as before. Less is more. We label our triangle. So opposite the right angle, my hypotenuse. Opposite the angle we're given, the opposite. and the remaining side, the adjacent. Okay, great. So we've labeled our triangle, and now let's look at the equations. So the equations are, for trigonometry, Sohcahtoa as well as Pythagoras too, but we just need Sohcahtoa for now. So Sohcahtoa. So now we need to select the irrelevant equation. That's the first of the S's. So we want the adjacent. We have the opposite. So that means we're going to use TOA because this contains the opposite and the adjacent, 2 ticks. So we've selected our equation. Now we can write it. So we have tan of 55 degrees is equal to opposite divided by adjacent. Well, the opposite is 8. And my adjacent, I don't know. It's just a question mark. Very mysterious. So now we really have a similar problem to the ones that we dealt with over here. These ones here in part 2 of the starter. 4 equals 2 over x, times both sides by x, divide both sides by 4. It's very, very similar to what we just had. So for the last of the letters in the acronym, we want to solve this. So I'm just going to write it again here. Tan 55 is 8 over question mark. I'm going to call question mark x, if I may. I'm just going to call that x, just so it's a little bit easier for us to. I'll tell you what. I'll call it. I'll call it x, if I may. So I've got 8 over x. So we want to get x on its own. We want it to be the numerator on its own side of the equation. So I'm going to get rid of the x on the right-hand side by multiplying both sides of the equation by x, or x over 1 if you want. So on the right-hand side, I get x over x, which cancels to 1. So I have 8 times 1, which is just 8. On the left-hand side, I have x multiplied by tan 55. I'm going to leave it like that. I'm not going to say tan 55x. I'm just going to say x times tan 55. So I have x times tan 55, which is 8. Great. I want x on its own, so I'm going to divide both sides by tan 55. I am not dividing both sides by the number 55. I am dividing both sides by tan of 55. I will show you how to put this into your calculator too. So on the left-hand side, tangent of 55 will cancel out because I just got, the same number. If I've got a number divided by itself, it just cancels to 1. So I end up with x is equal to 8 over tan of 55. I will show you 2 ways to put this into your calculator. So you can either put this in as, let me just get that out of the way. You can either now say, okay, I want fraction button 8 over tan 55, close bracket. That is fine. You can do that. Just a bit more visual. So we end up with 5.60 centimeters to 2dp. But you might prefer just to say 8 and then divide 8 divided by tan 55. And it gives you the same answer. So it's up to you. Because really fractions just represent the solutions to a division problem. So let's go over to the next example. So example number 2, we want to find the missing side here. And I'm going to call this one y, if I may, just because I prefer to write y than a question mark. So again, let's label our triangle. Opposite the right angle, that means our unknown is the hypotenuse. Opposite the angle that we know, that gives us 4 as the opposite. And then the remaining side, which we haven't yet labeled, is just the adjacent. Okay, great. So we've labeled our triangle. Look at the equations. Never hurts to write make sure you write these down in the exam, so the examiner knows you know what you're doing. If you make a mistake, Sohcahtoa, we want to select the appropriate equation. So we want the hypotenuse, and I have the opposite. So that means I'm going to use sine. So I've selected my equation. I've got my equations written, selected them. Now we're going to write the equation down and solve it. So we have sine of 47 degrees is equal to opposite, which is 4 over the hypotenuse, which I have called y, the question mark, which I don't yet know. Same procedure, same as before. We're going to multiply both sides by y first. so that we cancel out the y's on the right-hand side, because obviously timesing by y is the opposite of dividing by y. And on the left-hand side, I have y times sine 47. So then that gives me y times sine 47 degrees is equal to 4. And then finally, to get y on its own, I can divide both sides by sine of 47 degrees. So on the left-hand side, sine 47s will cancel out, leaving me with y is equal to 4 over sine of 47. And we can get that on our calculator as follows. We could do 4 over sine 47, close bracket, which will give us 5.46, I believe. Yeah, 5.47 centimeters, the two decimal places. So the next one, let's have a look at one more example, and then you can get on with an exercise. So I'm going to call the missing angle this time Z, if I may. So again, less is more. Let's label our triangle. Right, so we want the hypotenuse. The opposite is not relevant to us. We have the adjacent, because that's what remains. So we've labeled our triangle. Equations, Sohcahtoa. Okay, let's select our equation now. So we have the adjacent and we want the hypotenuse, which means that we are going to select cosine. So you've selected, you've got the equation. Now let's solve. So we have, well, let's form our equation first. So cosine of 72 degrees is equal to the adjacent 8 over the hypotenuse, which I have called Z. Same procedure as before. I don't want the Z on the bottom. I want it to be the numerator on its own. I want it in the form Z is equal to solution. So I multiply both sides by Z, which will cancel out the Z on the right-hand side, because Z over Z is just 1. So I have Z times cos of 72 degrees is equal to 8. So to get Z on its own, I can divide both sides, different color, divide both sides by cosine of 72. So if I just get back to black pen, that will give me Z is equal to 8 divided by cos 72, or indeed 8 over cos 72. So let's work it out. So 8, I'll do it with division this time just to show you can do it this way. 8 divided by cos of 72, close bracket, giving me, no, why do I not? I don't really trust that solution too much. So let me just give one more look. Cos 72 is the adjacent of the hypotenuse. I don't trust that. 8, hypotenuse, cos 72. No, that is right. 8 divided by cos 72. Let me check it on here. Yeah, that is right. Okay, so then we get 25.89 centimeters. Again, paying attention to the units, to 2 decimal places. Okay, so hopefully that is fairly straightforward. It's really not much more than what we've had to do before. My part, I don't know why this is doing this. There we go. Not too much more than what we've had to do previously. So what I'd like you to do now is to find the missing sides of the triangles below. So that means AB for the first one, BC for the second one, not BC for the second one, AC for the second one, AB for the third, and AB for the fourth. So pause the video now, have a go, and then we'll go over the solutions. Okay, so for the first one, you should have AB equal to, sine 65. So AB, tell you what, I'll do it this way. So for this one, you should have sine 65 is equal to 5 over the unknown, which I'll just call AB because that's what it is. So if you want the side AB, you would just have 5 over sine 65, which gives us 5.52 centimeters, or well, there were no units here, so we'll leave the units out, but generally you'll be given units. Second one, you should get sine, not sine, you should have tan, because obviously you've got the opposite and you want the adjacent. Tan 70 is going to be 6 over AC, which will mean that AC, if you rearrange that as we did before, is going to be 6 over tan 70. So AC is going to be 2.18 centimeters, or whatever the units are. For the next one, you should have cosine 65 is the adjacent 3 over the hypotenuse AB, which means that AB is going to be 3 over cos 65. So AB is going to be, let's do that, 3 divided by cos 65, we get 7.10. And lastly, we want to get AB for the last one. So for the last one here, we have the opposite. We want the hypotenuse, so we're going to use sine. I'm going to say sine of 20 degrees is equal to the opposite 3 over the hypotenuse AB. Rearranging as before would give us AB is equal to 3 over sine 20 degrees, which gives us 3 divided by sine 20, which is 8.77, whatever the units are. So hopefully, you've now marked your solutions to the exercise and you've been able to get the same answers. So a rather short lesson this time because, in fact, there's only one more skill for trigonometry that you need, and that is finding missing angles and then practicing some, past paper problems, extending your knowledge by doing more and more practice. But for now, just to get an introduction to that, we're going to look at a GCSE question. Or really, it's a question that I've adapted from a GCSE paper to make it more relevant to us. So this is basically the problem that we talked about before, with a slight change. So a boat is out to sea. The angle of depression of the boat from the top of the cliff is 15 degrees, as shown. So that means if you look at a straight line jutting out from the top of the cliff, then there's a 15-degree, you'd have to go 15 degrees clockwise to be, directly in line with the boat. So that's the angle of depression. We think of it as angle of depression because it is going down from the cliff, like that. Angle of elevation would be that. Okay. So the height of the cliff above sea level is 188 meters. We want to know how far out to sea the boat is. So this is like a realistic navigation problem. So not exactly like this, but you might have a problem where there's a lighthouse and you want to know how far the lighthouse is from the boat, things like that. They do use this in real life, in navigation, in air traffic control, various things like that. So there is a little twist here. So if you want to have a go at it now, just pause the video, have a go. Otherwise, I will give you a hint. So the hint is, well, that is your hint, ZFC. That is your hint. If you want an even more revealing hint, just wait for a second, I'll give you another one. So the more revealing hint is, let's get this. Remember your parallel lines. So you've got a line at the top here, parallel to the line here. What do we know about the angles which are alternate from each other? Well, we know they're equal. And at this point, that's all the help I'm going to give you. Pause the video, have a go, and then we'll go over the answer. Okay, so hopefully you realize that we could model a situation. If I just get rid of these, hopefully you realize that we could model a situation as a nice right angle triangle. So remembering first of all that we have alternate angles. So the angle of elevation is also 15 degrees because it is alternate to the angle of depression. So hopefully you realize we've got 15 degrees here. We have a cliff which is 188 meters high. And we want to know how far out to sea the boat is. Well, we could think of that. We could call that X, the unknown side X. Then if I just move this out of the way. Let's move this to. Then we could consider this as a standard right angle triangle problem because obviously the cliff is at right angle to the sea. We can model it that way. It might not be exact, especially not in Southern Down where you've got really slanty, Sutton stone. But we're going to model it as a right angle. So again, less is more because we want to find an unknown side of a right angle triangle. This is our scheme. We label our triangle. So hypotenuse is there. The opposite is 188, and the adjacent is what we want to find. So we want to find the adjacent. We have the opposite. So that means I'm going to be using, well, we've labeled it, equations, don't forget the equations. Sohcahtoa. So we have the adjacent, we have the opposite, we want the adjacent, so we're going to use tangent. So we've selected tangent. So now we can form our equation. Tan of 15 degrees is going to be the opposite, 188, divided by the adjacent, which I have called x. We want x on its own, so I'm going to multiply both sides by x. So I get x times tan 15 is equal to, well, x over x is going to be 1. They cancel out, so I just get 188. And then I can divide both sides by tan 15 to leave x on its own, which is what I want. So that gives me, they cancel, so that gives me x is equal to 188 divided by tan 15. Let's put that into our calculators. So we can either write it as a fraction with modern calculators. You might not have a calculator with that function, which is no problem. You can just do 188 divided by tan of 15. And if you don't have a calculator with that function even, you could do tan 15. So an older calculator, you'd have to do tan 15 equals, and then you'd have to do 188 divided by ans, and then equals, same answer. And you get 701.63 meters. The question wants our answer to the nearest whole number. Integer just means whole number. So that means we get a final answer of 700 meters. So the boat is about 700 meters out to sea. So that's all there is to this lesson. The last thing that we need to do now is to use trigonometry to work out missing angles. So you might have a problem. If you look at this problem here, you might have been given the cliff is 188 meters high. The boat is 700 meters out to sea. What is the angle of elevation of the top of the cliff from the boat? You might well get that as a question. Next lesson, we're going to find out how to do that. Very straightforward. Thank you so much for your attention. If there are any problems, just let me know on Teams.